Hello, Lamai. I hope that you can hear me clearly, no?
Yes, sir,
Am I audible clearly? For the one last time?
Quite clearly.
Yes, sir.
Yeah, great. So today we are going to start a very new lesson. In the last week, I told you all basics about mathematical applications and some of the basic theoretical applications regarding this lesson. Right? So today it is all about the application of simple harmonic motion. In the last week, I prepare you for this. So there are some other new students here. I don't know whether you have done this lesson before or not. Give me 1 second. There are new names here. Adira. Nishadya. Adira, Nishadya and Pilini Sanika. These are the new names. I want to know one thing. I just need to know one thing from you guys. Have you done this lesson before? Most of the classes have never thought of starting. Only few classes have started. Have you done this lesson before? Tagala, yes, they know the kira kraddan. Let me know whether you have done this lesson before or not. That's it. That's the only thing I want to know. Haven't done yet. Okay. The other ones, Adira said, haven't done. The others started last week. Okay, very good. There is one more student who is new in this class. I have never seen her before. Nishadya Dayadi. Yes or no? That's the only thing I want to know. Nishadya, I'm talking to you. Everybody replied because in my students, I know they don't know. They are just about to know this lesson for the first time. Nishadya කියන ළමයා දිව්වා. Okay. Forget about it. Now we are just about to start this brand new lesson. It is absolutely new, right? This lesson is perfectly new one. So we just need to apply our theory knowledge. In the last week, I reminded you about simple what? Circular motion part. So the entire circular motion you don't want. No. You don't want the entire circular motion. But you need somewhat. පොඩ්ඩක් ඕනේ. මෙන්න මෙච්චරක් විතර. So I just revised that part. And in the other one, you may need some mathematics of just tallying x of something with a of another. I told you the method and how to apply. There are some of those things and you will get to know. Don't worry. I will teach everything beginning of the lesson, even though I gave them a very big training session. Right. By the way, I am now going to start the lesson. Before that, I want to tell you one more thing. This lesson will come up with many practicals. Actually, I am planning to do some practicals like simple pendulum, and mass attached to a string, and many other like finding mass of unknown mass of test tube, and many other. So this comes up with some practicals. I am going to perform the practicals here. You are going to write down the readings what I'm giving you and find out the relevant things. Because this lesson may come up with certain practical in your structured paper, right? So you should be able to write the answers for those. And also, I assure you, this lesson all will give you somewhere like 5 to 8 marks itself. 5 to 8 marks itself. Simple harmonic motion part only. Because we are just about to start unit 3. The unit 3 consists of mainly 3 parts. Unit 3 consists of mainly 3 parts. First one is the one I am going to teach you today, simple harmonic motion. And the second one is waves. And the third one is optics. Simple harmonic motion, waves, and optics. Okay, Laman? So, I'm repeating again. Simple harmonic motion, waves, and optics. This is the second largest lesson. Second largest lesson in the syllabus. But I have to tell you one thing. Whoever your sir, that the other one said like Adira or the other one, I can't remember her name. No. I didn't send the tute yet. You are always worrying about the tute. I told you. I am sending you the
Your mic seems to be muted.
I told you the physical tute will apply to you after 2 weeks after the first class. By the way, how will do that? So in this part, this first one is like will take somewhere like 3 to 4 weeks maximum, maximum of 4 weeks, including today. Including today. This one will take at least like 6 to 8 weeks. 6 to 8 weeks. So normally this may take at least like 6 to 8 weeks, and this may take like 4 to 6 weeks according to your speed. It depending on with your speed, but I take this much, but some others may take it like 6 to 7 to 9 days to finish this one, and they may take like 10 to 12 days to finish this one. But it is not that hard, but they stretch because you know the reason. There are like incapable students, really incapable, not just incapable, many more, like majority of the students are like hard to get the S pass even. Majority. So they need the majority, or they try to stretch this lesson. But in my class, I'm really 100% confidence in my students. So they can cope up with this speed. I am not like skipping like this way. No, I'm not like a frog. Teach everything, take the time, explain everything, do more questions, but finish this. Don't worry, new ones. So the lesson is going to be today's lesson, simple harmonic motion. I will give you an introduction before waves started, and I will again give you an introduction about optics started. Today's thing is waves. Sorry, simple harmonic motion. Whoever the others who has started this lesson last week, he's a great guy somehow. Because many other guys I have seen, they take long time to come to this part. It is a sin. Right, by the way. So let me show you one more simple motion of this stick. This is a good example for simple harmonic motion. Then, see, This one is a good example of simple harmonic motion. And rotation of a fan is a good example of simple harmonic motion. And a water wave ripple is a good example of simple harmonic motion. So the simple harmonic motion is everywhere. But what we are going to do here is, what we are really going to do here is going to have deep take a look at inside into the subject, right? Going to have a deep look at into the subject with some mathematical structure. So, and also, have you seen any hacksaw blade? Right? Vibration of a hacksaw blade like this. That is also a good example for simple harmonic motion. So this one is nothing other like many simple mathematical applications. So one thing I have to tell you, there is a thing called restoring force. What? Restoring force. Do you have any idea about restoring force? Yes or no? Let me just know. Restoring force. Force, you know, the physical quantity which can make difference in certain object is known as force, but restoring force. Yes, very good. Very good, Sudarshini. The force exerted by water when an object forcefully immersed. That's a really good example. Restoring. Yeah, force that will act on the system to bring to equilibrium. Really good. Sahas is absolutely correct. Because, by the way, the force that will bring the object back to the equilibrium position, Tilini, really good. New ones are also really good. So, good look at this one. This is a plastic slinky. Now, I am going to stretch this. But this spring acts as if a string. For best example is a string to explain. I will give you the technical terms and everything. But before that, I have to give you some clear idea and background, make the background and go into the lesson and give you all the definitions and everything. Before that, I want to make your background and make your mindset for the lesson. Okay. So for a string, what can I do? I can just try to stretch this string using the force of F. Okay, now you can see there is a force. At the beginning it is 0. Now you know there is a force according to this extension of x. According to this extension of x. So you know that the force is what? Proportional to this extension. Right. So once you stretch something, it will generate some force. Once you release that force, this force created by the system itself, bringing this thing back to the equilibrium position. So restoring, again, so have you heard this word? Hair restoring treatment. Hair restoring treatment. Newspaper you can see that in newspapers and stuff. Hair restoring. What is the meaning of restoring? අමු තට්ටේකට කොණ්ඩේ හිටවනවා නේ මරු මේ Facebook ad එකක් දැක්කලා ඉතින් Facebook මේ meme in that one they say තට්ටේට තිත දැබීම it is like a Dallas type of online product තට්ටේට තිත දැබීම wow interesting no so there was like a bald guy and a guy come and mark a dot on the scalp and go like that. Restoring means bringing it back. Have a good look at. I'm applying a force. That force is storing in this one. Once I release, it's going to get back to the original position. That is the one called restoring force. Okay. That is the only thing I want to show you here in physically. And now I am going to move to my regular and very beautiful but drawing board. Because on that drawing board I can show you everything with in detail. You know, all of my students know, but the newcomers might be really wondering what is that man is going to do. That is the only reason why I took like 1,000 rupee charge from you, because that will retain you for like at least like the end of the day. Then you will tell me whether continuing or not. If you are saying no, then I'll pay you 1,000 and send you over. But the problem is, if a new one randomly come, once I just turn off my camera and share the screen, they just get afraid and leave the class. Then they don't know how I teach and what is that advantage of that board. Nothing. They just get afraid and leave. It is really not good. So stay here, learn until the end of the day. Let me know your feedback. You may free to go, and I'll deposit your stuff back. Don't worry about it. Arned? Okay, Lamai? Okay, let's go straightly into our new lesson. Simple harmonic motion quickly. I'm going to give you now theoretical knowledge. Still, I just gave you the background and I laid the foundation. The foundation stuff is all over now. Now it is all about theoretical things. Let's go for the theory, basic, original theory of that. Okay, Lamai? Are you ready for that? Huh? Okay. For the new ones, I'm going to turn off my screen and everything. You will not see me, but you will hear my voice and you will see everything on certain digital screen, and you will get to know everything if you stay. I'm pretty sure you will get deep understanding, because I can explain everything on the board, but I can't show you some scrutinized important detail. How? Because there is no way in this board that I can move objects from one place to another. No. Only I use this board to explain some theoretical and practical applications. I do the practicals here and plot the data and let you know. Okay? Right. I'm going to go to that board quickly. Hello, Lamai. Can you see me and hear me on that and see this so-called shared screen? And can you hear me? Because I'm going to start theoretical parts of simple harmonic motion right now, quickly. Okay, Lamai? Right. Wait. I can hear that. See that? Okay. Now reply to this device. I am just going to send you a certain weird message. So reply to this device. Oh, I have sent it to a personal someone. Wait. I have to send it to everyone. Wait. This one to this device. Okay, Ramai. Write the big topic. Simple harmonic motion. Simple harmonic motion. harmonic okay. Just before learning simple harmonic motion, we have to learn about the motion, type of harmonic motion. Right, Lamai? Firstly, we have to learn about kind of harmonic motion. So, what about harmonic motion? Write this in a new line. If an object, if an object, if an object if an object repeat the same motion, repeat the same motion, repeat the same motion again and again, again and again, repeat the same motion again and again, with some fixed time interval, within some fixed time interval, fixed time interval, the object is said to be in, the object is said to be in a periodic motion, periodic motion, periodic motion, says to be in a periodic motion, right? Periodic motion, said to be in a periodic motion. Okay, let's write a one example. And this is going to be a practical even. In the next week, I am going to perform that practical and get the results. So first example is, right, motion of a simple pendulum. Write the first example, motion of a simple pendulum. Motion of a simple pendulum. I said like the periodic motion yet. This is not the definition for simple harmonic motion, Lamai. This is about periodic motion. මේ board එක තේරුම් ගන්න ඔයාලා ටික වෙලාවක් යයි ළමයි. You will get a certain time to get adjusted to this one. But you will see how important this one, because in the regular board I can't show you this type of motion even. The object move like this. So how can I show? So this one contains many advantages. Okay, this is the first example for what? Motion of a simple pendulum. The second example we can take it like motion of a mass attached to a spring. Motion of a mass attached to a spring. Okay, this one will move up and down. Here the mass will move up and down. Up, down, up, down. Right? Now write motion of a clamp hacksaw blade. Motion of a clamp hacksaw blade. Right. Clamp hacksaw blade. Clamp කරපු hacksaw blade එකක්. Okay. So I have to ask you one question. Have you ever seen this clamp hacksaw blade?
Have you seen these things, this scenario? A hacksaw blade which is being clamped. ගෙදරදී කරලා බලන්න පුළුවන්. Okay, I will repeat the second one. Second one is motion of a mass attached to a spring. Motion of a mass attached to a spring. Motion of a mass attached to a spring. The third one is motion of a clamped what? Hacksaw blade. Hacksaw blade කියන්නේ ළමයා නිල් පාට පොඩි කියත් පටි තියෙන්නේ. අන් එකක් අතින් අල්ලලත් වැඩේ කරන්න පුළුවන්. You can do the same thing. You can repeat the same thing by holding a small hacksaw blade by your own hand and let it oscillate. And the third one we can take it like motion of a water column in a YouTube. Motion of a water column in YouTube. Okay, now have a good look at here. If you let certain water column to stay like this one is nearly above the other. Once you release, this one firstly exerts a certain force. It wants to stop. It will rise back to this point, and this point goes down. Now it is going to be certain very nice back and forth motion. Goes up, goes down, goes up, goes down. So along the YouTube, you can see this one move back and forth like in this manner. Okay? Understand, Laman? Yeah, right that. Motion of a prongs in a tuning fork. That's a good example, Sudarshini. That's a really good example. Motion of a prong in what? That's a really good example. Motion of a prong in tuning forks. Enough of writing these simple examples. Right. This is the periodic motion, but in simple harmonic motion, it should be kind of specific. Simple harmonic motion, that should be kind of specific. Right? Simple harmonic motion. We normally ask this definition in the exam. You may have to write the exam definition in the exam. Okay. Now write the definition of simple harmonic motion. Very small subtopic. Definition of simple harmonic motion. Right? Definition of simple harmonic motion. Okay. My students know how to write the definition. You are even you are my temporary students know. So I normally use a hashtag or $sign to write the definition because I never use star point to definition because we use the star points to write certain important point. But remember, definitions are extremely important because in the exam they directly ask. The second thing is, if you have good understanding about the definition, you can easily do questions. I'm not telling you to repeat the definitions like a parrot, right? I'm not telling you to repeat the definitions like a parrot. No. It's not like that. Oh shit, I drew this. You might not see this one. Use a hashtag or $sign like this normally. Okay. Or whatever specific symbol you have. Okay. The motion of an object the motion of an object around the mean position. Around the mean position. Open the bracket and write equilibrium position. Equilibrium position. Motion, right? Motion of an object around a mean position, and in a bracket write it like equilibrium position. Equilibrium position. Okay, equilibrium position. And continue to write, close the bracket, right? In which the acceleration of the object and acceleration of the object and restoring force directly proportional to the directly proportional to the displacement directly proportional to the displacement from the mean position. Displacement from the mean position. Okay, let's see what is the displacement and what is the mean position, everything. Okay, write this in a new line, Lamai. The best example to take this is a mass attached to a sorry, oscillation of a mass attached to a spring. Oscillation of mass attached to a spring. Oscillation of mass attached to a spring. You want me to repeat? Which part, Sanuka? Which part am I supposed to repeat?
The line you just said now, sir. The line that you just said.
I can't exactly repeat the same line I said. The best example to take this is a mass oscillation of a mass attached to a spring. Okay.
Okay, thank you, sir.
Okay. Now see, here there is no motion. There is no motion. Yeah, you can't see any motion here, ne? There's no motion. And how about it? There's no motion and no extension. No force. Restoring. There's no force at the beginning. Okay, what I'm going to do is, now I am going to extend this string by means of an external force. I am now going to move this one like this using some external force. Let's see how does this affect now. Okay, now you can see there is a definite extension there to the right in the positive direction. Mass is there. Now you have applied the force of F. Right. Now the problem is the spring generates a force inside it using some tension. So because of the spring constant, that force is always against the motion of displacement. Can you understand? Right? So there is a force now. Because have you completed this part successfully in your mechanics? Lamai, I'm asking from the new ones. Have you successfully completed this part in your mechanics in your class? If not, I may have to explain you about the spring constant thing. Lamai, I'm asking from the new three. Yeah, Adira say yes. Astadya said, Trini said yes, very good. Then you may understand this one because now, right, as the external force is applied, right, this as the external force is applied, as the external force is applied, the spring may get extended. The spring may get extended. The spring may get extended. As the extension becomes certain displacement of x, as the extension becomes certain displacement of x, the spring itself generates. The spring generates a force. The spring generates a force itself. A force itself in the opposite direction. In the opposite direction towards what is that point? Equilibrium position. Equilibrium position. We used to call this initial position as the equilibrium position. Equilibrium means there is no motion, no force. That is the equilibrium position. Understand? Or we can say it like mean position. We can say it like mean position. You can say it like mean position. Do you need me to repeat it? Okay, I will repeat. Once an external force is applied on the spring, I'm repeating this. The spring may get extended from the mean position as it reached to certain displacement of x, the spring itself generates a certain opposing force in the opposite direction of external force. In the opposite direction of external force. In the opposite direction of external force, which is towards Where? The equilibrium position. I told you, no? Right? The restoring force is towards directly proportional to x, but the force is towards the mean position. Okay, I was talking about certain acceleration even. Okay, now write these things in a new line. If the mass is released, if the mass is released, mass is released from the external force, mass is released from the external force due to the restoring force in the restoring force in the spring, due to the restoring force in the spring. Now, what is the law may apply now? There is a restoring force, there is a mass. What is the law now apply? Going to apply. Let's check your physics understanding. What is the law that is going to apply? In the paper, they ask questions like this. What is the law going to apply? Then what the heck are you going to write now? Oh, no, not F equals to Kx is an equation. It is not a law. It is not a law, my dear. I'm asking, there is a certain specific law that is going to apply here. I badly want to know about that law. Can you please tell me? Oh, not Hooke's law, my dear. It is not about Hooke's law. When there is an unbalanced force, restoring force is an unbalancing force. Sahas is really good. Hooke's law is the law of the spring. Now I'm talking about the force act on the body. It's really beautiful law, you already know. No, my dear, it is not the third law. It is the second law. Write that. According to the Newton's second law of motion, Newton's second law link according to the Newton's second law of the motion, Newton's second law of motion, the object get an acceleration. The object get an acceleration. තේරුණා නේද? මම හිතනවා හැමෝටම මොක තේරෙන්නේ නැති කියලා. එහෙම නේද ළමයි? I hope everybody understood this. ළමයි, yes or no? Now we can represent this diagram here. Have a good look at. Now I have released. Now there is no external force there. Now there's no external force. I have released the spring now. I have released the system now. Now this force is no. There is no external force. It is zero. But the spring force is there in the negative direction of the x. Because of this x and the Newton's second law of motion, there is a definite acceleration like this. On the local acceleration, can you understand? Can you understand it? Copy these whole diagrams, all three diagrams together. මෙන්න මේ diagrams තුනම දැන් ටක් ගාලා පොතට දාගන්න. Copy this. It is really easy to understand this. There is no such rocket science behind this. Darusi, you seem to have kind of network trouble today, ne? Copy this one quickly. If you have done copying, just let me know. Because I don't like to waste time. Ramai, if you decided to do, in the first day you decided to do A-level maths or science, that means you firstly you have to dedicate yourself towards the subject. Again, subject එක dedicate වෙන්න බැරි නම් හරි අමාරුයි මේක කරන්න. So in my classes, I don't deliver like those things like what fun facts and most like motivational speeches. I deliver motivational things time to time, not all the days, because it is all about study. My aim is to finish the study. ඒ කියන්නේ නිකම් බහුබූත කියවන්නේ නැහැ. සමහර ළමයින්ට ඒකට කැමතිත් නැහැ. සමහර තෝනේ පොඩ්ඩක් අර ආතල් දෙන්න. ළමයි මම මාර ආතල් එකේ ඉන්න මිනිස්සෙක්. හැබැයි මගේ ප්‍රොෆෙෂන් එකේදී මම කැමති රිසල්ට් එකම විතරයි. Right? So I'm telling you to the new ones because all the ones know about my characteristics. Here in this class, I'm not going to grab those like no future type of guys, because if you are coming to my class, you should be someone like what? Workaholic. වැඩ කරන්න කැමති කෙනෙක්. Then this is your class. If you like fun seeker, I'm not. In my general life, day-to-day life, I'm actually the most funniest dude in the world. But here in this class, I maintain some standard, doing more theory, more questions, more work during the week. Also, boys ලා ටික දන්නවා. girls නම් දන්නේ නැහැ. මම කොච්චර ෆන් එකේ ඉන්න බුලට් එකක්ද කියලා. කොල්ලෝ ටික මගේ යාළුවෝ ටික වගේනේ. But in my class, I don't deliver those like funny things. වැඩක් නෑ ඒවා කතා කරලා. හරි. ඔයාලා ready ඇති නේද වැඩේට? Okay, done. Great. Okay. ඔයාලට jokes ඕන නම් ළමයි ඔය මේ පොඩි ෆිල්ම් එකක් කරන් බලන්න පුළුවන් නේ. ඔය පැය දෙක තුනක් concentrate කරන්න බැරි නම් A level math science කරන්න හොඳ නෑ. මොකද මේ ඔයාලට තියෙන යුනිවර්සිටි වල එහෙම තියෙන වැඩ දැක්කම එහෙම විශ්ව වැදෙනවා. අර වැඩ තෝගයක් තියෙන මේ A level මොනවද කියලා හිත. හැමදාම exam. සතියකට weekend එකක අනිවාර්යෙන් exam. semester එකක් ඉවර වෙද්දී නිකන් මරවනවා. අවුරුදු දෙකේම ඉගෙන ගන්න දේවල් වගේ 4-5 ගුණයක් තනි semester එකකට ඉගෙන ගන්නවා යුනිවර්සිටි එකක. ඒකට A level එකට ඔයාලව හදන්නේ කොහොමද මේ බබ්බු වගේ හුරතල් කර කටපාඩම් කරව ඒවා හරියන්නේ. හොඳට explain කරනවා. හැබැයි අර හුරතල් කිව්වේ නෑ. හරි නේද? අලුත් තුන් දෙනාට මම මේ කියන්නේ. my method is really different. දවසක් ඉඳලා තේරුණොත් ඔයාලට තේරෙයි මු කරන්නේ විදිය තමයි හරිම විදිය කියලා. I mean right now experiencing. සේහත්. මගේ ක්ලාස් එකේ පටන් ගන්න හිටපු ටුට්ටක් කම්මැලි කොල්ලෙක්. parallel degree එකක් කරන්න ගත්තා. Now he is experiencing so much of troubles. No, sir? Because why? They are just giving enormous amount of workload. මේ level වගේ නෙමෙයි. level කියන්නේ විහිළුවක්. ඒ level එකේ අපි කටපාඩම් කරලා උරතල් කරලා විහිළු කතා කියලා ගානක් හදන්න දැම්මගේ මොලේ හිරි වැටෙනවා. විහිළු කතා කියලා ඌව කොහොමාරි අමාරුවෙන් මේක අච්චුවකට හදලා පාඩම් කරවලා කැම්පස් එකට පැටවුවාම ඒකට වැඩ කරන්න බෑ. අපරාධය අම්මලාගේ සල්ලි. ඒ නිසා මෙතන ඉන්නකොට මම කරන්නේ කෙලින්ම යථාර්ථයම වෙන්න. කැමති උන් ඉදී අනිත් උන් යන්නේ. Right. Okay. Now, write the next subtopic. Sorry. Now write this. Now the Hooke's law. Now by combining. Now by combining. Now by combining Hooke's law. Sorry. Hooke's law and Newton's second law of motion. I just wrote like N2. It is not nitrogen, na? N2, Newton's second law of motion. The following result obtainable. What is the result? On the object in the spring. The restoring force provided by the force is F and the extension is X. Mass is M. There is an acceleration of A. So what is it? F equals to Kx minus Kx. And from Hooke's law, the other one is F equals to MA. Number 2. Okay. Let's link them together. Number 2 is equals to the number 1. And let's see that MA equals to minus Kx. Okay. What is A? A is equals to minus K x over M. Okay. What are the constant things in this one? You can see that acceleration is varying. What is K? K is spring constant. K is what? The spring constant. Okay, that is the constant thing. What is A? Acceleration. It is not a constant, it is variable. This one is variable. This one is variable. The next part, X. What is X? Extension. This one is also variable. This one is also variable. Now there is another thing, but mass. Mass is constant. This one is constant. Why? Constant for this system. For this system. Can you understand? It is only constant for this system. You have to just understand. Lamai, just give me a 1 second. Okay. Can you understand? The spring constant is definitely constant for that spring. It is a constant anyhow, but this mass is a constant for this system. Yeah, we are taking oscillations for only this mass. That is why it is constant. Really good, Sudarshini. Sudarshini, then ළඟදී නම් හොඳට වැඩ කරන්න ආරා. She's a really good girl now. See her answer. Right. හොඳ ළමෙක්. Ananta Kumar is a really good girl. This is her answer. We are taking oscillations for only this mass. That is why it is a constant. Really good, Sudarshini. Now I can take the constants only. This is Sudarshini's answer. Now I am going to separate these constants only. A equals to, I will write negative here. And X out. And these constant things together. K over M. Okay. Now can you see these? I just separated out these constant things. And I will write that in capital K means a different constant. Because constant and constant, I am getting this to a common constant now. Acceleration equals to negative capital K x. X එක ළඟ ලිව්ව වැඩි. K. Can you understand this? Do I have to explain this again? Do I have to repeat this again? Am I supposed to repeat this again? No. Can you understand by the first impression? තමයි. Doubts තියෙනවා නම් ටක් දාලා කියන්න. If you have any doubt, just please let me know. It is clear. Wait. Very good. Copy this. Now we know this equation as the characteristics equation of simple harmonic motion. Write this. Once you write this special point. This equation is the characteristic equation of simple harmonic motion. Copy this. Characteristic equation of simple harmonic motion. And write this one as equation X. I will just tell you where to apply this equation with the circular motion. Those who have done this equation lesson, you may have seen this equation. So also told us like the characteristic equation is this. No, don't write this. I will let you to write this one in the right position. Yeah, this is the characteristic equation. But I have to teach some more things and give you this note in tally with rotational motion. හරි නේද? ඒක නිසා දැන් මෙතනට මේක ලියන්න යන්න එපා. Erase this. හරිනේ? මම හිතනවා හැමෝටම clear ඇති කියලා. I expect that it is clear for everybody. Did you copy this thing? Because I want to move to the next point, please. Let me know. Yeah, I'm pretty sure you are the most happiest person in the earth now today, no? Not only the most. One of most the happiest persons in the world now today. Because the worst cricketer in the world scored the half century. But nothing is going to matter because Sri Lanka team is going to lose the match. Okay. Right. Characteristic equation of simple harmonic motion. Right. Now write this point and we have to go for some other points. there are some real specific characteristics of simple harmonic motion, right? Understand? There are like certain specific characteristics of simple harmonic motion. Okay? Special characteristics. Now write specific characteristics of simple harmonic motion. There are like basically 5 characteristics. Let's see. Characteristics of simple harmonic motion. The first one is amplitude of the simple harmonic motion. First one is amplitude of simple harmonic motion. First one is characteristics of simple harmonic motion under the topic of characteristics of simple harmonic motion. It's here. The first small subtopic under that is amplitude. Sorry, O level hitiana. If you are in your O level, please let me know what is amplitude. ඔයාලා O level knowledge එකෙන් කියන්න බලන්න. Symbol is capital A. We measure that in meters. Can you remember your O level?
So like the maximum displacement and
Maximum
oscillation,
what?
the displacement during an oscillation in the wavelength.
Yeah, really good. But for A level, we have to be specific and precise with words. Really good. I'm still saying this is a really good answer, but I need some specific with some specific wordings. කියමු බලන්න. Do you have any idea? Okay, I'll give you the note. So, right, the maximum displacement of yeah, it is like maximum height of one wave of oscillation. Yeah, not one wave. We have to write specific with the simple harmonic motion. The maximum displacement of an object in simple harmonic motion, an object in simple harmonic motion from its equilibrium position. Okay, this is the equilibrium position. So if this one is the maximum displacement, we call it like A. We call it like A. So for simple pendulum, උන්චිල්ලාවක් තව හරි යාළුවෙක්ව පද්දනවා නම් your friend is in the swing and you are going to push him, right? This is also kind of simple harmonic motion. The maximum displacement is A. Okay. For example, තව ගමු. For a hacksaw blade even. This is what amplitude. For regular water wave, this is what amplitude. Okay. Copy these things quickly. Example. As examples, copy these things. For spring mass system, for a simple pendulum, hacksaw blade, and regular wave. Copy those things. We have to be specific with wording. What are the wordings? The maximum displacement of an object in simple harmonic motion. We have to tell that. And the next specific wording is from the point of equilibrium or equilibrium position or mean position. ඔන්න වචන ටික තියෙන්න ඕනේ නැත්නම් වැරදි දාන්න. Okay. Copy. Lama, did you copy these things? Please let me know. Okay, great. Now write the next point. Yeah, great. Now write the next point. Okay. Next one is periodic time of oscillation. Periodic time. Okay, what is that periodic time? You may know this, but I will give you some basic explanations as well. But I'd like to know your idea about periodic time. Periodic time. Is it in seconds? Tell me, what is your idea about periodic time? The definition, if you know. If you know, I would like to give you a chance. Yes,
Time
very good.
for a
Sudarsini. Huh? Sudarsini is one.
one complete of
Yeah, you are trying to tell the answer. I can see that the answer is clear, correct? But your signal level is seem to be horrible. So has tried to speak. Okay. Okay, no problem. So far I can see that the students know the answer. But the time taken for one complete oscillation of an object in simple harmonic motion of an object in simple harmonic motion. I'm repeating that again. The time taken to complete one complete oscillation of an object in simple harmonic motion. Okay. I am going to go for that swing thing. Let's go for that swing. Swing means simple pendulum. It starts from here, move to this bottom, and reach to the other end. That is not the full cycle because you started from here and you move to there. It is not completing. It has to come back to original position. Then only it complete. You have to understand that because now it is like this circular motion. Now imagine an object going to start from here, right? Now the object finishes at here. It's just 3/4 of the cycle, half of the cycle. Sorry, quarter of cycle, half of cycle, 3/4 of cycle, complete cycle. That means the finishing point should be the starting point again. So for the string, what is it? Starting from here, it has to come back to the original position back. Then only complete the complete cycle. So let's see for the hacksaw blade. Like the same case. It has started from here, have to move to there, and will have to come back to the original position. Okay. And for spring, I'm releasing it from here. This is the equilibrium position. It comes to the equilibrium position. Will that stop here? No, 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 no. Because of this velocity and the kinetic energy, it will compress this one and move past here and reach to the other end. Only half of the motion gone. Now it will have to come back to the equilibrium position again. It won't stop and it will come back to the original position. So this is the whole cycle. Can you understand? The time taken is at the beginning it is 0. At the end, time taken is capital T. Here as well. What is it at the beginning? T equals to 0. At the end, T will be capital T. Here also, is to start at the time of T naught and finishing at the time of periodic time. Started at the moment of T equals to 0, finishing at the time of periodic time. Copy these whole 4 diagrams. If you don't understand any of these points, please let me know. Okay, ළමයි completed diagram. ළමයි ඔය ටික ලියාගෙන ඉවරයිද? Did you complete the diagram? Right. Okay, ළමයි. Finished. This is what the good example for periodic time. Now let's get one another thing. Okay, now write this in a new line, please. In the last week also I let you to write the relationship of the relationship of relationship of periodic time and circular motion. Circular motion. Lamai, you know what? This board is I normally use this one because of one specific reason why. At the end of the class, I give you a PDF of all the board drawings. Board drawing of Dala. Okay. What is the relationship? Can you remember? I'm asking from the new students because all the students know because I complete that in circular motion as well as in the last week. So, new ones? Any of you three, please? Adira, Tirini, or the other one, what is the name? Uncommon names he had. Nisadya. Any of you three, please let me know if you know the relationship. If you don't know, please let me know. So, no, sir, no problem. Haven't done circular motion yet. Oh my God, Uday, Uday, Nisadya. You are in a horrible position if I say you, because you have done 1 year and 3 months already now in A level. That means still you are doing the second lesson, unit 2, and not finished. Not finished. Isn't that horrible? Even there is one girl here. She's from Gautami College. She's also a new girl. Amaya, you told me your story, no? You have only were doing like Newton's laws. Do you know what? We started Newton's law end of January. End of January. මෙන්න මේ අවුරුද්දේ ජනවරි වල තමයි නිව්ටන්ස් ලෝ කරේ. ලොකු අවුලක් තියෙනවා. And there are all about 9 more units to go. 9 more units to go. තව දෙයක් කියන්න ඕනේ ළමයි. 9 more units to go. තව දෙයක් කියන්න. අද උදේ මට කතා කරා අම්මා කෙනෙක්. මගේ කතාව කියන්නම්. Is there anybody who can't understand any basic Sinhalese? Please let me know. කවුරු හරි සිංහල තේරෙන්නේ නැති කවුරු හරි ඉන්නවා නම් කියන්න. මේ there are like 1 or 2 Tamil and Muslim students, because I would like to tell this story in Sinhalese. මේක සිංහලෙන් කිව්වොත් හොඳයි. Afla, how about your Sinhala understanding? Akila Aslam, how about your Sinhala understanding? Afla said that she understands really well. Akila Aslam, how about your Sinhala understanding? You understand too, okay? And there seem to be a one Tamil student. Adira, are you a Tamil or Sinhalese, Adira? Normally this name comes after Tamils. We had a friend called Adira as well. Adira Muslim? පුදුමයිනේ. Adira කියන්නේ මේ Tamil name එකක්. Okay, Adira, how about your understanding? Sinhalese. I know Ananta Kumar can understand really well in Sinhalese. Okay, very good. හරි මම මේක සිංහලෙන්ම කියන්නම් ළමයි. මොකද ඒක සිංහලෙන් කිව්වොත් තමයි හොඳ. සිංහල ළමයි කොහොමද දන්නවනේ? සිංහල වෙලක් සිංහල දන්නේ නැත්නම් ලොකු අවුලක් තියෙනවනේ. හරි. මේක සිංහලෙන් කියන්නම්. අද උදේ අම්මෙක් කතා කරා. හරි. සර් ගිය අවුරුද්දේ සර්ගේ සෙමිනාර් එකට අපේ දුව ඇවිල්ලා තිබුණා. මම කිව්වා හොඳයි. ඊට පස්සේ කිව්වා මොනවාද මේ සර් අපේ දුවට ෆේල් කිව්වා. මම කිව්වා හොඳයි. අම්මා උඩ යන්න ඇති එකපාරට හොඳයි නේ කිව්වා. ඇවිල්ලා තිබුණා කියන්නේ එක දවසක් නිකන් ඇවිල්ලා දුවලා කියන එක. සර්ගේ නම කියන්නේ ටිකක් ජනප්‍රියම කරා. ඊළා තිබුණා. ඊට පස්සේ කරලා තියෙන වැඩේ කියන්නද? මම ඇහුවා ඉතින් ඇයි මේකට ඇවිල්ලා නෑනේ සර් මොනවද ඒ ලෙවල් වලට පොඩ්ඩක් ටිකක් අර ස්ටෑන්ඩඩ් සර් කෙනෙක් ගාවට යන්න ඕනි කියන අයිඩියා එක තිබුණා. මම කිව්වා එහෙමද? ඇත්තටම මගේ කියන්න ලැජ්ජ නැහැ ගිය අවුරුද්දේ මොකද දන්නවද මේ 2023 මගේ බැච් එකේ හිටියේ කීයද දන්නවද? ඒ ලෙවල් ලියන්න හිටියේ 4යි. Only 4 students I had in my class in taking first. Only 4 students. මොකද අපේ මූණවල අලුත්. ඒ පස්සේ අම්මලත් හිතන්නේ මේ මේ සමහර අම්මලා කෝල් කරලා අහනවා ඔයා තාම අන්ඩර් ග්‍රැජුවේට්ද ඔය වගේ කතන්දර අහනවා. මම ඒ හින්දා දැන් ඉතින් පොඩ්ඩක් රැවුලවල් කොණ්ඩවල ඔයාගෙන ඉන්නවා මේ නැත්තම් එහෙම උන් ඒ වගේ කතන්දර අහන්න නිසා. හරි. එතකොට ඔයගේ ප්‍රශ්න තියෙනවා යාලා හිතන්නේ යා මේ අලුතෙන් ආපු අරකයි මේකයි හරි කමක් නැහැ. හතරයි. Only 4 students. Out of these 4, there is a 1B and 3 C's. මේ මතක තියාගන්න ඔය හතර දෙනා සෙට් වුනේ මුලින් ඉඳන් නෙමෙයි යා. They just get to my classes like in the last 8 months because I just decided to give some kind of what this type of private promotions and they just got to know about me and they randomly came into the class like in 3 sessions no ආවා විනාඩි 5යි ඉන්නේ දුවනවා ඉන්නවා විනාඩි 5ක් ඉන්නවා යනවා උන්ට තේරෙන්නේ නැහැ නේ මම කරන්නේ මොකද්ද කියලාවත් තේරුම් ගන්න ඉන්න එපායි අර කියන දුවත් එතකොට ඔය විනාඩි 5ක් ඉඳලා මිසින් වෙච්ච කෙනෙක් හතර දෙනයි 1B and 3C මම ඉතින් ඔක දාන්නෙත් නැහැ මොකද B එකක් දාපුවම හරියන්නේ නැහැ B දාන්නේ අර ඒ ගොඩක් ඒක දෙකුත් දාලා ඒ එකක්වත් නැහැ මොකද හතර දිනකින් මට හැබැයි මේ B එක ගත්ත කොල්ලත් නූලෙන් මිස් වෙලා ඇත්තේ ඉතින් අනිවාර්යයෙන්ම යුනිවර්සිටි 2A 1B engineering කතන්දර දෙකක් නැහැ he's also slim dude called Asperg හරි සුපිරිම කොල්ලෙක් ඔන්න ඔක තමයි රිසල්ට් එක ඒ කියන්නේ අපි අලුත්නේ හිතන්නේ අලුත් උන්ට වැඩ බැහැයි කියලා නාකි වෙන්න ඕනේ කට්ටේ තියෙන්න ඕනේ ඔක තමයි එයාලගේ රික්වයර්මන්ට් එක අපේ ලංකාවේ ඕක තමයි උන්නේ. හරිද? 23 බැච් එකේ නම් යමක් කරයි මට හිතෙනවා අයිලන්ඩ් රෑන්ක් එකක් වගේ දාන කෙල්ලෙක් ඉන්නවා මාර මීටරයක්. අනිවාර්යෙන් කෙල්ල. ෆිසික්ස් වලට නම් එකක් දානවා. අනිත් සබ්ජෙක්ට් දෙකත් ඒ වගේම කරනවා නම් ඉතින් අයිලන්ඩ් රෑන්ක් එකක් තමයි. එතකොට මේ ඒ වගේ සෙට් එකක් ඉන්නවා 23 එකේ නම් හරකට වඩා 22 ඔන්න sorry 22 බැච් එක ඔය විදිහට කරුණා. දැන් මේ ළමයා නිකන් ඔය විසිට් එකක් දාන්න ඇවිල්ලා ආපු ළමයි. හරි. ඊට පස්සේ දැන් ඔප්ෂන් එකක් නැති කමට මතක් වෙලා මගේ ගිහිල්ලා බලලා කොහොමගේ දාලා තියෙන වීඩියෝ මම මේව බලලා සර් මේ සර්ට කරලා දෙන්න බැරිද 23 එකට දාලා මම කිව්වා ඇයි එහෙම කරලා දෙන්නේ නෑ සර් මේ ළමයාට මේ මොකද මම ආව ගිහිල්ලා කරන්න මම ඒකට මොනවද කරේ එතකොට එයාලා කියලා තියෙන්නේ මගේ සෙමිනාර් එක දැම්මේ මට මතකයි මම දැම්මේ අන්තිම මාස කීපයකනේ මම මුලින්ම දැම්මා කරන්ට් ඉලෙක්ට්‍රිසිටි අන්තිම මාස 6 මුන් ගිහිල්ලා තියෙන හේතුව දන්නවද කරන්ට් ඉලෙක්ට්‍රිසිටි වලට ඇවිල්ලා විනාඩි 5ක් විතර යද්දී මුන්ට කරන්න හිතලවත් නැහැ මම අද කෙල්ලගෙන් දැනගත්තේ එදා එයාලා දුවන්න හේතුව එයාලා ඒ වෙනකොටත් ඉඳලා තියෙන්නේ වේව්ස් වල මේ අපි තාම මේ සිම්පල් හාමොනික් මෝෂන් එකට එහා පැත්තේ එක සිම්පල් හාමොනික් මෝෂන් වලට එහා පැත්තේ තියෙන එක තමයි වේව්ස් එතකොට මම කරන්ට් ඉලෙක්ට්‍රිසිටි කරද්දී අර ළමයින්ට තේරෙන්නේ නැහැ නේ අන්තිම මාස 6 අන්තිම මාස 6 last 6 months ඔන්න අතන්දරේ හොඳම සීන් එක නෙමෙයි දැන් මම කරන්ට් ඉලෙක්ට්‍රිසිටි එක දාපුවාම අර අස්පක්ලා වගේ මීටර හොඳ ළමයි ටිකේ තුන් හතර දෙනෙක් අතර වුණා අනිත් තුන් ටික ගියා හරි හොඳ මාතල් එක ඔක නෙමෙයි last 3 months වල සිලබස් එක ඉවර කරගන්න බෑනේ රෙකෝඩින් සෙට් එකක් දෙනවලු එක සතියකට රෙකෝඩින් 5ක් විතර දෙනවලු ඒ කියන්නේ ස්ටුඩියෝ රෙකෝඩ් කරපුවා ක්ලාස් රෙකෝඩින් නෙමෙයි ස්ටුඩියෝ එකක රෙකෝඩ් කරලා එක සතියකට වීඩියෝ 5ක් විතර දෙනවලු ලෙසන් එකක මේ ටික බලා ගන්න. කොහොමම දීලා අන්තිම මාස් 3 පට්ට වීඩියෝ තෝගයක් දීලා. හැබැයි හොඳම සීන් එකක් මේකයි වීඩියෝ එක තියාගන්න දෙන්නේ නැහැ. අද වීඩියෝ එක දානවා කියමුකෝ. දවස් දෙකකින් විතර වගේ වීඩියෝ එක ඩිලීට් කරනවා. ඒ කියන්නේ සතියකට සතිය ඇතුළත කොහොම හරි ওই වීඩියෝ 5 බලන්නත් ඕන. කොහොම සිලබස් එකක් කවර් කරන්න පුළුවන්ද කියන්නකෝ. මම සිංහලෙන් අහන්නේ. කොහොම සිලබස් එකක් කවර් කරන්න පුළුවන්ද මිනිස්සුන්ට? මම අහන ප්‍රශ්නෙට උත්තර දෙන්නකෝ. කොහොම සිලබස් එකක් කවර් කරන්න පුළුවන්ද මිනිස්සුන්ට? ඔව්ද නැද්ද කියන්නකෝ. මට පොඩි උත්තරයක් දෙන්න. ඔව්ද නැද්ද? මලාට කරන්න බෑ. මිනිස්සෙක්ට නම් කරන්න බෑ. රොබෝ කෙනෙක්ට නම් ටක් ගාලා දුන්නා කොපි කරගත්තා හරි. මං කියන්නද ඔය මිනිස්සුන්ගේ තට්ටේ පෑදිලා තියෙන්නේ ඔය වගේ බලු වැඩ කරනවා. ඔය මිනිස්සුන්ගේ තට්ටේ පෑදිලා තියෙන්නේ ඔය වගේ බලු වැඩ කරලා තමයි. වෙන හේතුවක් නෙමෙයි. තේරුණාද? හරි. ඒක නිසා බය වෙන්න එපා. මං හරි විදියට කරන නිසා මට කොහොමත් සත්‍ය නම් පෑදෙන්නේ නැහැ. ඒක වෙන්නේ. සත්‍ය නැති වුණාම ළමයි එන්නේ නැතුවයි දන්නේ. එහෙම කේස් එකක් තියෙනවනේ සත්‍ය පෑදෙන්න ඕනේ ලංකාවේ. කතන්දර ගොඩක් තියෙනවා. ඉතින් පුතේ ඔයාලා ඉන්නේ පොඩ්ඩක් අවුලක. මම ඒකයි කිව්වේ ඒක ළමයිගේ සිම්පල් හාමනික් මෝෂන් මේ වෙද්දි පටන් ගමන් තිබුණා කියලා කිව්වා ටිකක් කවුරු හරි කමන්නේ හොඳ සර් කෙනෙක්. මොකද ළමයි ගැන හිතලා පොඩ්ඩක් වැඩ කරන මිනිස්සෙක්. කවුරු හරි ඒ වගේ මිනිස්සුන් අපි අගය කරන්නත් ඕනේනේ. කවුරු හරි මිනිස්සෙක් ළමයි ගැන හිතලා ඉක්මනට කරලා තියෙනවා. හරි. Okay. Have a good look at. ඔය කියන විදිහට තම රොටේෂනල් මෝෂන් කරලා නැහැ කියන්නේ මාර කරුණයක් තා. වීඩියෝ දෙයි පට ගාලා. Still there is a chance to win. Yeah, Sanuka. Still there is a chance to win. අනිවාර්යෙන්ම chance එකක් තියෙනවා ඔයාලට විදිනන්න. මොකද අවුරුද්ද කරලා තියෙනවා. You have like almost 1 year. හැබැයි ඔතනම හිර වෙලා හිටියොත් ඔක ප්‍රශ්නයක් තියෙනවා. මං කියන්නේ මයි ගාවට මෙන්න කියලා. කවුරු හරි සිලබස් එක ඉක්මනට හොඳ ඉවර කරන කෙනෙක් ගාවට යන්න. මං කියන්නේ මයි ගාවට මෙන්න කියලා. මොකද මම ඔයාලට සෙට් වෙන්නත් ඉන්න තියෙනවා නැති වෙන්නත් ඉන්න තියෙනවා. ඒක වෙනස් වෙන්න පුළුවන්. ඔව් සිංහල medium folks doing thermal physics. Definitely. සිංහල මීඩියම් වලත් ඉන්නවා ඔය අලුතෙන් ආපු සෙට් එකක් හැමෝම නෙමෙයි අම්මට සිරි ඔය ඉන්නවා මේ මම නම් කියන එක හරියන්නේ ඔය අලුතෙන් ආපු නිකන් අර යුනිවර්සිටි අයියා කෙනෙක් ඉන්නවා මිනිහා තවම කරන්නේ මොනවද දන්නවද මේ එනර්ජි රිලේෂන්ෂිප්ස් එනර්ජියා සිංහල මීඩියම් එක සමිත සර් වගේ සුපිරි සර්ලා තමයි තර්මල් පැත්තට ගිහිල්ලා තියෙන්නේ හරි රොටේෂනල් මෝෂන් කරා සර්කියුලර් මෝෂන් දැනවි පටන් ගත්තේ කියන්නේ රොටේෂනල් මෝෂන් නොකර කොහොමද කියන්නකෝ දරුවෝ සර්කියුලර් මෝෂන් කරා ඒක විහිළුවක් වගේ හරි මේ අහන්නකෝ ඒ කොහොම ගියත් ඒ ලෙසන් එක ඉවර වෙලා එන කාලයක් වෙන්න ඕනේ හොඳටම බලන්න මෙන්න මෙහෙම t equals to 2 pi over omega හරි t equals to 2 pi over omega සර්කියුලර් මෝෂන් නැතුව රොටේෂනල් මෝෂන් කරන්න බෑ මෙන්න මේක අග්ගල් ලියගන්න you know what is t periodic time t equals to pt and omega equals to angular velocity ඔක මේක නම් ලොකු ට්‍රේනින්ග් එකක් කරගලන්න දුන්නා ගිය සතියේ. ඔයාලට ඕන නම් මම කන්ටිනියු කරන ළමයි ඉන්නවා නම් ඔයාලට එන්න අපෝයකි මම ගිය සතියේ කරපු රෙකෝඩින් එකක් දෙන්නම්. මැතමැටිකල් ට්‍රේනින්ග් එකක් දුන්නා සෑහෙන. ඒ මැතමැටික්ස් ටික ගොඩක් අද ඇප්ලයි වෙන්නේ නැහැ ලබන සතියේ ඇප්ලයි වෙන්නේ. එන ළමයි ඉන්නවා නම් කියන්න මම රෙකෝඩින් එක දෙන්නම්. ආවත් නැතත් දෙන්නම්. මොකද ඔයාලා යන දැනක ගිහලා වැඩක් කරගන්න එපේ. ඒක ඔයාලා ආවත් නැතත් මම රෙකෝඩින් එක දෙන්නම්. So now write frequency. Next subtopic is frequency. 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 What is frequency? Now write the definition. Now write the frequency. Sorry, definition. Number of oscillations per unit time. Number of oscillations per unit time. Of oscillations per unit time. සහස් මතකද මම ලාස්ට් වීක් එකේ කිව්වා අපිට මේ වෙද්දි හීට් ඉවරයි කියලා. ඒ සමහර සර්ලා තව මේ ස්පීඩ් එකේ කරනවා. හොඳයි. Number of oscillations per unit time. Okay. Now write relationship of what? Frequency and periodic time. What is it? 1 over t. equals to 1 over t. And I can substitute this t to here. See, what is it going to be now? F equals to what? Omega over 2 pi. And also you may remember this equation, omega equals to 2 pi f. ඔන්න ඔය කියන relationship set එකම ඔළුවේ තියෙන්න ඕනේ. Right? Write this in a new line. There are certain relationships. There are certain relationships and characteristics in simple harmonic motion. In simple harmonic motion. In simple harmonic motion. Likes of displacement, velocity, acceleration, right? But studied under future lessons. මේක අන්තරේ තව ටිකක් ඉස්සරහින් කරන්න. Now write this in a new line. According to the frequency and triple star point. According to frequency and periodic time. It is obvious that simple harmonic motion and circular motion are interconnected. මම ඔයාලට කියවනේ ළමයි අර prerequisite knowledge නැතුව වුණත් මේ lesson එක කරන්න පුළුවන් කියලා. Didn't I tell you? Because I can teach these things right now and carry on with the lesson. Because this lesson is nearly free from most of the mechanics. ඒ mechanics parts ටික අමාරු ඒවා නෙමෙයි. ඒ නිසා අලුතෙන්ම පටන් ගන්න පුළුවන් lesson එකක්. වැඩි දන්න දෙයක් නෑ. Okay. Now write the characteristic equation can be rewritten as following: kx. So this one I can just rewrite in this manner: a equals to negative omega squared x. Actually this is what the characteristic equation. ඇත්තම characteristic equation එක මේක. Copy this. A for acceleration, omega for angular velocity, x for displacement. X for displacement. Okay, I'm going to give you an example question. Let's see how is your understanding level. Example question. Okay, I'm going to give you the characteristic. Now let me know whether you have finished up to here copying this part, and I'm going to show you, give you like an example question now. Done. Very good. Write the example question. The characteristic equation of an object which is in simple harmonic motion, is in simple harmonic motion is given below in the following equation. So is given as what? Now write it. A equals to minus 16 pi square y equals to 16 pi square y. 16 pi square y. Now questions are like this. Question number 1. Find out the angular velocity of the particle. Number 2, find out the periodic time. Number 3, find out frequency. Number 4, what is the acceleration? If displacement is 5 centimeter? Okay. Now get your answers. Amen. දැන් මේක දිහා බලාගෙන කියන්න එපා සර් ඔයා ලියපුවම පේන්නේ නැහනේ කියලා. මම ඔය ලියන්නේ විහිළුවට. ඔයාලට මම ඒවා ටික සිරුවනේ ලියාගන්න. මම ඔය නිකන් ඔය මට කම්මැලිකමට ඔය ලියාගෙන යන්නේ. Medically the company come. I want to repeat karana. Number 1, find out the angular velocity of the particle. Number 2, find out the periodic time of the particle. Find out the frequency of the particle. Last question is, what is the acceleration if the displacement is 5 centimeters? තත්කාල හදම් බලන්න. ඔයාලා අද මේ කියන දේවල් ටික සිහියෙන් අහගෙන හිටියා නම් ගේමක් නෑ. සිහියෙන් නෙමෙයි නම් හිටියේ කරන්නම බෑ. හරි. I'll give you එක ප්‍රශ්නයකට විනාඩි 2 ගානේ දෙන්නම් විනාඩි 8ක්. I'll give you some 8 minutes for you to do this question. විනාඩි 8ක් යන්නේ නැහැ පුළුවන් එකට විනාඩි 2කින් පුළුවන්. කොකටද දෙන්නම්? හිමීට අද නෝට් එක කියවලා බලලා අන්තිම ටික. කොහොම හරි කමන්නේ. සමහරවල් උත්තර දානවද කොහෙද දැම්මම? My microphone is muted. No, man, I'm speaking. මේ අනිත් ළමයින්ට මාව ඇහෙන්නේ නැද්ද? මගේ microphone එක muted ද? නෑනේ. Is that my microphone muted? ළමයි? මාව ඇහෙන්නේ නැද්ද? නෑනේ ඇහෙනවා මధుරි. There is a problem from your side for sure. Okay, now I'm giving you your time. Sorry. මම හදනවා ඔයාලට මේ විතර ආවද කියලා බලන්න. Check whether you can do this one like this way. My little brother is always liking to see your YouTube shorts. පොඩි ළමයි ආසරි මම විකාර වැඩනේ කරන්නේ. How old your little brother? Yeah, because of the animations. Yeah. In these days, I don't have time because otherwise I would really make few videos like that. Yeah. Just 4. Oh my God. Just 4 years old. Oh, it's too small. No? You know what? There is one of my cousin brother. He's elder to me. He's like, he's like, I think now 34. And there is another, his younger brother. He has a sister. She's like 3 years younger to him. And his younger brother is exactly 18 years younger than him. Can you imagine? හැබැයි වැඩේ කියන්නේ අපේ අයියා තාම නිකන් පොඩි එකෙක් වගේ ඒක නිසා උන්ගේ පේන්නේ නැහැ එහෙම ගැප් එකක්. Exactly 18 years younger. Okay. So angular velocity. Let's find out angular velocity. ළමයි හොඳට බලන්න. I told you this is what the standard model equation. What is it? This equation is called what? Standard model equation of simple harmonic motion. Okay, that means characteristic equation. A equals to minus omega square x. This is what our equation is. But here we have given this equation for this particular motion. I have to write it. Minus 16 pi square y. Now, this I told you, no, omega means it is a constant thing. This one is resemblance to this equation. Minus kx. K means constant. Omega is a constant. And 16 is a number. Number is a constant. Y is a number. That is also constant. So, these are constant things. These are the variables. Now see, A is A, right? This one is resemblance to this one, right? X is resemblance to Y, that is also right. So I need omega. So here it is given like omega square is equals to 16 pi square. But in the question it is asked about angular velocity. Angular velocity means it is omega. Hari neda. Angular velocity means it is omega. Omega equals to square root of 16 pi square. So omega is what? 4 pi only. Understand? Omega is 4 pi only. Hari neda? You got the answer correct. Very good. Afla. අම්මා අපි දිනුම්ද මැච් එක? I don't like so because Kusal Mendes the man of the match යනවන්නේ ඒකයි මම කමෙන්. Otherwise I like. අරුන් අර ටාගට් එකක් තියාගෙන ගැහුවේ ඒකයි මේ වුනේ නැත්තම් අනිවාර්යයෙන් මුන් දිනනවා. Sarina, now I have somewhat thrilled. I solved the question correctly in 2024 class. Sarina, you know what? This girl Sarina is not a 2024 girl. She's a 2025 girl. She joined to this class and she's just about to finish her A level within 1 year. She's a really good girl. And Sanuka is also 25 guy. He's also going to finish the exam in 1 year. Right? So I told you, so Sarina ඇත්තටම ආවේ rotational motion ඔය වගේ දේවල් කරනකොට. ඒ කියන්නේ ඒවා මැදින් අල්ල ගන්න බෑ. මුලින් ඉඳන් අල්ල ගන්න ඕනේ. ඒ ඇවිල්ලා එක දිහා බලාගෙන හිටියා. ඔක්කොම තියරි තේරෙනවා සර් ඇප්ලයි කරන්න බෑ ගණන් හදන්න බෑ. කොහොමද නැහැ බලන් ඉන්නේ කියලා. දැන් මම කිව්වා මේ ලෙසන් එක මුලින් ඉඳන් අල්ල ගන්න පුළුවන් එකක් නේ. දැන් අල්ලගෙන වැඩි. හරිනේ. ඒ පොඩි ළමෙක්ට පුළුවන් නම් ඔයාලට බැරි වෙන්න බෑ. Because this is a good example to see, right? See, is the first time, absolute first time. Huh? You can start with this lesson easy. අනිත් දේවල් කිසි දෙයක් ඕනේ නැහැ. අද කියන දේ හොඳට අහගෙන හිටියා නම් පුළුවන්. Now find out the periodic time. Okay. I told you there is a relationship between periodic time and rotational motion. See here, this one. I can use this one again. What is it? හොඳට අද කියපු දේ අහගෙන හිටියා නම්. For the question number 2. T equals to 2 pi over omega. What is 2 pi? 2 pi is 2 pi. Omega is this one. What is it? 4 pi. Pi and pi cancel off. 2 and 4. Just cut over. T equals to 0.5 seconds. හරි නේද? තේරුණාද ඕක? ළමයි, can you understand what did I say? සුදර්ශනීගේ answers ටික නම් ඔක්කොම හරියා. සුදර්ශනී your answers are correct. Okay. Right. Third one. It is about frequency. I told you frequency is 1 over T. So what is 1 over T? 1 over 0.5. Oh, that means it is 2 hertz. Unit is hertz. අනේ ළමයි මම periodic time frequency කියන එකේ මම units දැම්මේ නෑනේ. දාගන්න ඕනේ. Frequency symbol is F. Unit is hertz. And sometimes we can use this alternative unit, but S minus 1 as well. ඔන්න ටික frequency කියලා දාපු දෙන්නට දාගන්න. ඕන මෙයි. Okay. Now the very last thing. If the displacement is given like 5 centimeter, what is the acceleration? Okay, my regular equation is what here is given like a equals to 16 pi square times y. Okay, now here y is given. Y is the displacement. Y equals to 5 centimeter. Now let's apply. Acceleration equals to 16. Pi means pi square times 5 times 10 to the power minus 2 because 5 centimeters. So I repeatedly have said you Ananta Kumarget mam podi avulak dakinawa, you have forgotten this. I told you, you can approximately get pi square is nearly as of what? මතකද? pi square කියන එක nearly කීයද කියලා ගන්න පුළුවන්. ගත්තට කිසි වරදක් වෙන්නේ නැහැ. I repeatedly told you. 40 ගන්නවා. pi square කියන්නේ 40ද? 10. මේක 10 කියලා ගන්න ළමයි මම කට ගන්නකම් කියලා තියෙනවා. minus 16 times 10 times මේවා 4 whole answer එකනේ කිව්වේ minus 2. okay. ඉතින් මොකද වෙන්නේ? කපලා දාන්න පුළුවන් minus 1 16 times 5 either 18. It is like 80 and 10 gone is going to be 8 what? ms minus 1 minus 8 ms minus 2. May answer kawada wala? Namai, did you get this answer? Sorry na ඔක්කොම ටික හදාගන්න හොඳ ළමින් යනවා. හරි. අමායා okay, you can leave now. No problem. You have to farewell him. Go. Okay, Sanuka, you may go. Yeah, that's why you got like 7.90. Okay, good night, Sanuka. Only for Sanuka, අනිත් කට්ටියට නෙමෙයි. Sanukaගේ මාමරට යනවලු ඉතින්. එයාට මම යන්නද? ඔයාලගේ මාමලා දැන් කියන්න එපා. බොරු excuse කියලා යන්න එපා. හරි. දැන් කොහොමද මම ඔයාලට ඉන්ටර්වල් එකක් දෙනවා. හරි. I will give you like 10-minute interval. හරි මේ ළමයි. ඔය 10 minute දෙන්නේ කන්න බොන්න නෙමෙයි. හරිද? පැය තුනක් එක තැනක වාඩි වෙලා ඉන්න බැර නම් ඒරවල කරනවා මේකේ වැඩක් නැහැ. මං කියනවා මගේ උඩතල් කිව්වේ නෑ කියලා. මොකද උඩතල් කරලා හදන්නේ සතුන් ළමයින් නෙමෙයි. ළමයින් උඩතල් ගන්න අවුරුදු 2යි. ඒක නිසා වතුර ටිකක් බීලා මොන චුට්ටක් හොදගෙන වොෂ්රූම් එකට ගිහිල්ලා පොඩ්ඩක් ඇවිදලා විනාඩි 10ක් ඉඳලා එන්න. මොකද ගොඩාක් වෙලා දෙන්න බෑ. විනාඩි 10ක් ඉන්ටර්වල් එක අරන් පටස් ගාලා එන්න. අද මම පොඩ්ඩක් වැඩිපුරත් එක්ක කරා ටයිම් එක අල්ලලා. ඒක අලුත්ම ලෙසන් එකක් නේ. Let's do some calculations and stuff. Quickly go and come. Only 10 minutes. Okay. Meeting එකේ ඉන්න ගමන්ම mic off කරලා යන්න. නැත්තම් log වෙන්නත් ආපහු time යනවනේ. Okay. Interval lah. Question and similar thing. එකම දේ ආපහු පාරක් repeat කරපුවම හරියනවා. Okay. I will give you another example number 2. Okay. මම මෙතනදී දෙන්නේ equation එක විතරයි යා. A equals to minus 64 y squared z. මට මේකේ ඕනේ මොනවාද? Number 1 periodic time. Number 2 frequency. Number 3. Sorry. ඕන්න. හරි. ඔය දෙක හොයන්න පටස් ගන්න. බලන්න ළමයින්ට කොච්චර පුළුවන්ද කියලා. අද නම් තරුසීට මාර විදිහට සිග්නල් නැහැ වගේ. මම ඕක මේ ටයිම් එකක් දෙනවා එච්චරයි. ටයිම දෙන්නේ නැහැ. ඔයාලා හදන්න ඕනේ. ඔයාලා ටක් ගාලා හදලා දාන්න. Ah, yeah. It is 16 pi square descent. 16 pi square set. Yeah, man, it is damn easy. Yeah, it is very easy. Within the answers. Namo mother. Ah, Tilni Hari. Tilni, your answer is correct. Tilini's answer is correct. Afla, correct. Sharina, very good. Namo Hari. I got answers so far. Correct. Amaya, correct. Done, Hamo done answers. මං ඕකේ එක ප්‍රශ්නයක් අහන්න නැතුව හොරෙන් පැනලා ගියේ. ඔයාලට ඒක තේරුණාද කියලා බලන්න. I didn't ask one question. I just skipped that and moved to here. Adira, very good. Yes. Adira, correct. And Nisadya, I have no answer from you. නිසාද්‍යයාගෙත් හරි. කොහමගේ අර මේ usual ළමයි ටික D1 D2 D1 D2 very bad. D1 D2 කොහමේ D1 D2 D1 D2 D1 D2 සත්‍ය නැතුව ඉන්නේ මොකද? D1 D2 ට මේක සෙට් නැද්ද ලෙසන් එක? D1 D2 let me know whether it's hard for you or something, because I didn't get any answer from you. You two are my best students in this class so far. D1, D2. D2 provide the correct answer. And how about D1? Where is this D1? D1? Where is this D1? Okay, correct. Everybody seem to have understood this one. According to this one, have a good look at minus 64 pi square z. So here this one is like a equals to minus omega squared x. එහෙම නේද? Okay, now what we can get is omega square equals to 64 pi square. So what I need is omega. මට ඕනේ omega. 64 pi square. Omega is 8 pi. මෙතන මං omega අහලා නැහැ. අහලා නැති වුණාට අපි දැනගන්න ඕනේ how to get periodic time. We know periodic time equals to 2 pi over omega. And I have to extract omega from this equation and substitute to here. Sorry. T equals to 2 pi over 8 pi. What? 2 and 2 cancel off. Pi and pi cancel off. T equals to 1 over 4 seconds. That means 0.25 seconds. ළමයි ඔයාලා දන්නවද? මගේ මෙන්න මේ බෝඩ් එක නිසා තමයි බෝඩ් එකට ඉතින් සිද්ධ වෙන්න තමයි මේ වෙද්දි මෙච්චර ස්පීඩ් එකකින් මම කරලා තියෙන්නේ. ඇත්තම කිව්වොත් හැමෝටම තේරෙන්නක් කරනවා. ඒ කියන්නේ හැමෝටම හොඳට මේක ඉන්ටර්ප්‍රීට් වෙනකනුත් කරලා. ක්වෙස්චන් උත් ගොඩක් කරලා. සිලබස් එකත් ඉක්මනට යන්න පුළුවන් උනේ මේ බෝඩ් එකෙන් කරද්දි. මම ඒකයි සාමාන්‍යයෙන් දැන් ඔය ෆ්‍රී ඔප්ෂන් දීලා ළමයින් අතුලට ගන්න නැත්තේ උන් ටිකක් මේක දැක්කම මම බයලා දුවනවා. දිව ගමන් හරියන්නේ නැහැ. යන මෙසේජ් එකක් දෙන්නේ අපෝ සර් කෙනෙක් කියනවා මේ අමු විශ්ව වැඩක් කරන්නේ හරියන්නේ නැහැ යන්න එපා කියලා. ඒක නිසා දවස් අවසාන වෙනකන් තියා ගන්නවා. එයාට සෙට් නැත්නම් එන්න නැතුව ඉන්න පුළුවන්. අඩුම ගානේ එයාට සෙට් නැති වෙන්න පුළුවන්. හැබැයි කවදාවත් එළියට ගිහලා බෑඩ් කමෙන්ට් එකක් දෙන්නේ නැහැ. එයා දන්නවා මෙතන ලොකු වැඩක් වෙනවයි කියලා. ඊළඟට මම යාගේ පේමන්ට් එක අපහු දීලා හරවලා යනවා. හරි නේද? Once you get that one, you can include this into the other equation here. Frequency equals to 1 over t. Here it is like 1 over 4, then 4 goes up 4 hertz. Or you can write it the same way, what? 4s minus 1, or whatever the way you can write the answer. හරි නේද? හරි නේද ළමයි? කියන්න. done? හරි. Are you ready for a new theory part? It is going to be a very important one. We are going to have an experiment in the next week even. අපි experiment එකක් කරන්න යන්නේ ඊළඟ week එකේ. So, are you ready to grab that theory? It is called theory of what? Simple pendulum. අලුත් වීඩියෝ එකක් මම රෙකෝඩ් කරන්නම් මේකට. මොකද දැන් මෙතනින් එහාට මිස් වෙච්ච අයට කෙලින්ම එතනින් නම් බලන්න පුළුවන්.